My name is Peter Skabla. I'm CFD support engineer, and in this video I will show you how to set external aerodynamics tutorial from scratch. I opened empty TCFD, and the first thing I need to set is TCFD file. I click on Save As, go to the directory where I have my STL file. In my case, it's on desktop in directory Burj Al Arab, because I will be using STL of Burj Al Arab. Here I write the name of my TCFD file, Burj Al Arab, and press OK. Next, I select simulation type. External aerodynamics, use virtual tunnel. I press apply and continue to tap simulation. Here I decide if I want to compute only steady state or steady state plus transient simulation. I'm going to compute only steady state simulation. Then I can select number of processors I'm going to compute with, and my computer has 6. Then there is a numerical order of my computation, and I'm going to use first order. Then there is a convergence check, which can improve the computation time and stop the simulation if my computation is already converged. I leave it as it is. I continue to physics tab. In physics, I'm going to compute with air and leave it as fluid defaults, and also as incompressible in this case, and the reference frame 1 atmosphere. So I don't need to change anything here. I can close this tab, press apply, and continue to reference frames. In reference frames, I have 2 default frames, static and rotating, but I'm not going to use rotating in this case because building is static, so I can remove it, leave only static, press apply, close, and continue to components. In components, I decide how my geometry will be meshed. First, I can rescale the geometry if I have it in different units than meters. Then I decide the number of components I'm going to compute, and in this case I will have only one component. Then I can decide if I want to compute with bounding box. With external aerodynamics case, it's very easy to set computational area with bounding box. So I check it. Good. And now, before setting bounding box, I load my STL file to see my building inside of computational area. I go to desktop, the directory with my TCFD file and STL. I select STL directory and press OK. Now the STL of my building, Burj Al Arab, is loaded into patches table. I select it, choose the type wall, and now when I press apply, building should appear in window with geometry. But first I need to click on the eye next to components. And now I can see building of Burj Al Arab. Okay, let's get back to bounding box. Bounding box allows me to set boundaries of my computational area very easily. At the moment, bounding box is cube with side 1 meter. But Burj Al Arab is large building which is approximately 300 meters high and 80 meters wide. So this bounding box is too small and I need to increase it. Also, if I want to compute flow of the air around the building, the computational area must be much larger than the building. And that's why I'm going to set the x-coordinate minus 500 to have at least 400 meters between inlet and the building. Then I also set the y direction, which is minimum in y, it's the side of my bounding box, and then the height, and the minimum can stay 0. Then the maximum of in x, which should be at least 1000, so that's the double of the distance which I have in front, because the turbulent part of the flow is happening behind the building, and that means that area behind the building is much more important for the results. Also, I want to compute the building from the other side, so I increase the bounding box in y direction to maximum plus 500, and I said that building is at least 300 meters tall, so I want to compute or set the bounding box at least double of that size, and that's why I will choose 700 meters. Now I have my bounding box around the building, and this will be the computational area. The arrows show the inlet patch and outlet patch from my computational area. I can change the flow direction from any other direction if I like, but this one is good. Bounding box is now properly set, and I can continue with pressing apply, and I can go to patches table. In patches table, I set the refinement levels for building Burj Al Arab and my boundaries of computational area. I want to set the refinement level only for Burj Al Arab, so I remove it from the group of the rest of the walls, and now I can change refinement levels to the ones we have in our tutorial. Then I want to decrease the refinement level on the boundaries, because it's not important to have mesh refined there. And now when I decrease it to 0, all walls changed the minimum and maximum refinement levels to 0 together. Also, the wall should be only the ground, and the rest of patches is not a real wall. I don't want to have wall condition there, so I use wall slip on those boundaries. Additionally, to get improved results, I want to use boundary layer on my building and also on the ground. I will be using 3 boundary layers, and I press apply. Then I need to set background mesh size. I know that in my tutorial I have background mesh size which is 20 meters cube with size 20 meters. From this perspective, it's quite rough, but on the building it will be refined. And also we have boundary layers there. Then I need to select internal point, and I can show it in the geometry, but now the sphere is too small, and if I want to see it and simply drag it, I needed to increase the size of it. Now internal point is still in computational area inside of my bounding box, and it is not inside of the building, which is important. It needs to be outside, otherwise the internal part of the building would be meshed, and that's not correct. Now I have my mesh set, so I can hide internal point, hide background mesh size, and I can press apply and continue to next part. But what's very important is the fact that more important than refining mesh is the size of the computational area. With small computational area, you will not able to get proper results. The size of computational area is very crucial because it influences results a lot. Also, maybe I should increase the computational area even more because it's large in y direction and in z direction, but in x direction, where the most of the which is the direction of the flow, in front the computational area is really small. So maybe I should increase it even more. I doubled the distances. It was very easy. I can simply press apply, and now the computational area is much larger. This is good computational area for tutorials or initial cases where you want to set some baseline and make just case running. But if you want to get proper results, I recommend you to use even larger bounding boxes with maybe huge computational area to be sure that boundary conditions does not influence your results. Also, to improve the mesh quality, it's possible to set internal refinement areas, refinement regions, but this is a tutorial which already will have large computational mesh and has boundary layers, so I will not add refinement regions here. If you want to see how to set refinement regions properly for external aerodynamics case, you can go to our wind turbine tutorial. I can close components and continue to speed lines. In section speed lines, I can specify number of speed lines, but there is no rotation speed in this case, so it does not make any sense. Then I can compute multiple points, but I will compute only one point with one boundary condition. I want to compute for more than 500 iterations. I will choose 5000 instead, just to be sure that case is converged properly. I can continue to turbulence, and here I can leave it as it is because K omega SST turbulence model is okay. Then inlet boundary conditions. Here I want to use fixed velocity and I want to use 25 meters per second in X direction. I can close it and continue to outlet boundary conditions. And here I don't need to change anything because I don't need to specify pressure in incompressible cases. Then initial conditions. Here again I don't need to specify any pressure because I have my reference pressure set in physics, and as initial velocity I set 25 meters per second in X direction. This is everything to initial conditions, and I can go to simulation controls where I don't need to change anything because those default values are pretty sensible and I don't need to change them for my tutorial. And the last thing is post-processing. In section post-processing I can set averaging window, which averages last 100 iterations in this case, and usually it's good to use somewhere between 5 to 10% of overall number of iterations to get properly averaged values. So in my case I have 5,000 iterations and I will be using averaging window 250. Then I can change report units and specify steering path. Next I can specify efficiency probe or select more of them. Here I choose inlet patch, then torque patch, but I do not have any ball rotating, and I can choose outlet patch. And this is everything to efficiency probe, which in this case will not be that important, but it allows me to have multiple graphs and convergence criteria. Then the important for external aerodynamics are forces. I add force probe. I select patches. I do not want all walls. I want only Burj Al Arab. Lift is in Z direction, but important drag is in X direction, which is correct. Then center of rotation is in 0, 0, 0, but there is nothing rotating, so it's not that important. Then I can change reference area, but I do not know the reference area of my building, and I can leave it as it is. I can change reference velocity. Then in this case I don't need blade-to-blade view or meridional averages, and I can add surface samples on Burj Al Arab if I want to know pressure on the building, and also save it into a file. And this is everything to post-processing and everything to my Burj Al Arab setup. I press apply, save the changes. I can click on check setup and it checks the case. It says case setup is okay, and if I want I can click on TCFD setup and continue to TCFD manager and mesh and compute the case. But this was only about setting the case up, and it's everything from my side. Thank you for your attention.